Tonight, as you settle into the quiet comfort of wherever you are, let your breath become an oar that gently dips into a calm, dark lake. With each inhale, draw the shoreline closer. With each exhale, let the day drift away. Now, imagine something softly impossible. You begin to shrink, not all at once, but gradually, peacefully, as though the world is expanding in a tender yawn around you. Your fingertips, the lines of your hand, the weave of the fabric near your wrist, each becomes a landscape. You continue to grow smaller until you're the size of a dust mote caught in a band of moonlight, hovering in the still air of your room. At this delicate scale, your home is no longer a home. It is a world of gentle horizons and towering mesas. The spine of a book is a cliff, the lamp's cord, a dark river, the rim of a cup, an unscalable wall, crowned in porcelain snow. The distance from your bed to your door becomes a pilgrimage. The hallway is a canyon sculpted by centuries of footfall winds. The kitchen, if you could ever reach it, lies beyond a quiet desert of floorboards, each grain of wood a dune with its own ripples and shadows. Breathe again slowly. Let the shrinking continue. Your neighborhood swells and lifts like a continent. Streets unfurling as silver tributaries, buildings blossoming into mountain ranges of glass and brick. Traffic lights become distant suns that pulse red, then green, then amber, their halos floating in the murk like tiny nebulae. The laundry flutters on a balcony, and from where you hover it resembles cloud fields migrating across a sky of concrete. You could spend a lifetime traversing these distances, measuring your days by the cadence of bicycle wheels and the hush of elevators. The soft curbs, the painted lines, the garden gates, everything is magnified and softened, familiar and yet so far beyond your reach that it hums with a new kind of wonder. Smaller still, your entire city stretches now as an archipelago of night islands, bridges as thin threads sewing water to land. Somewhere a window flicks off, like a star, winking from existence. Somewhere, a bakery opens and lets out a warm gust of air. Cinnamon, yeast, the promise of morning. From your vanishing vantage, you are a traveler between worlds, studying constellations of tail lights, tracing the sleek orbit of train cars that snake through tunnels as if the Earth were conducting its own secret astronomy beneath everyone's feet. There is a rhythm to it all, a planetary heartbeat scaled down to human patterns. You could map these cycles, memorize their seasons, and never exhaust their gentle regularities. The city is too vast, too intricate its avenues, its alleyways, its mirrored windows capturing and releasing the sky to be completely known in a lifetime your size. Smaller, the country around you swells and curves, coastlines becoming the hems of continents, mountains lifting like knuckles beneath the skin of the earth. At this scale, distances grow so quickly you can feel time pooling inside them. Traveling from one edge to the other is no longer a matter of hours, but of days folded carefully into weeks. Rivers become silver pathways stitched across valleys. Forests darken into seas of leaves, and deserts flare with quiet light at dawn, a pale wash that feels like memory. Even if you could ride the wind at highway speeds without stopping, the miles would line up before you like soft, unending dominoes. And yet, there is still a familiarity here. The map you once held in your mind as a child begins to glow. The names of places like lanterns you hung for yourself along invisible roads. Now let the last familiar handhold slip away. Shrink until your entire planet, this breathing sphere that shelters oceans and rain and cities asleep beneath clouds, gathers itself in the velvet. Earth turns like a slow thought in the darkness, a lucid blue-green syllable in a sentence written by gravity and light. From here, you can sense how large it truly is, and how small we are upon its skin, listening for weather, planting seeds, reading to each other in the lamplight. You can imagine circling it at the speed of a dream, and even then, you would need time, so much time, to trace each coastline, to count each wave kissing the shore. The planet's circumference rounds out to a number that fills the mouth. its diameter a figure too wide to hold without both arms and then some. It is a globe that can cradle all the days of your life and still have room for days you'll never see. And yet, as your perspective settles into this soft astonishment, the room expands again, the way the sky expands whenever you look up from a page and remember, there is more. Because even at this impossible scale, where continents are the sizes of thoughts and oceans are the sizes of breaths, we have only arrived at the threshold. Our home, as generous as it is itself a grain of sand pressed into an endless star-washed beach. To step beyond it is to accept that distance, at least in the heavens, is not a fence, but a lullaby. Written in units, the heart learns more easily than the mind. Moments, light, and patient comparison. So let us keep drifting outward, but gently, like a dandelion clock surrendering to the night breeze. Imagine the sun not as the hard glare that once warmed your afternoon walk, but as the patient hearth at the center of a dark house, throwing off warmth at a distance that can be crossed by light in a handful of minutes. Imagine that distance as a pause, a sip of air, the echo between your inhalation and your exhalation. Imagine the space beyond our planet as a quiet, mostly empty room where the few furnishings, planets and their moons, sit far apart, each wrapped in its own soft pool of gravity. The nearest lamp, the nearest chair, the nearest photograph on the mantel, all of them further than they look. In this quiet, curiosity remains our most faithful lantern. It does not rush, it glows. It allows us to approach impossible numbers with imagination's glove, to hold them for a moment without burning. When we say the word galaxy, we mean a bloom of stars, hundreds of billions spun into the shape of a spiral storm, each bright point a furnace with its own family, its own weather, its own chances. When we say Milky Way, we are whispering the name of our neighborhood in a language of long distances and long patience. The words do not need to be hurried. They prefer to be set down like cups on a table, warmed by palms, sipped between breaths. You might find comfort here, in the foregrounding hush of such scales. The larger the vista, the quieter the mind becomes, as though wonder works like snowfall, softening edges until nothing feels harsh or hurried. Our task tonight is simple: to walk with care across a bridge of comparisons, hand in hand with what we already know, toward what we can almost imagine. If your eyelids grow heavy, let them. The story does not mind. It will continue without the eyes, paced by the heart, which was always better at these distances, at forgiving how far, how long, how wide. We will count with light, we will measure with breath, and we will pause often, as travelers do when they turn to each other and say, "Look, do you see it too?" And if, in the hush, you feel a small feeling rise, the sense that all of this, from dust mote to city to sea to sphere, is one continuous thread, hold that feeling like a small, sleeping animal in your hands. Do not squeeze. Do not explain. Just listen to it breathing. On we go, slowly, together, toward the beach where our grain of sand lies, toward the spiral of stars that makes a home of the dark, toward a scale so large that the mind loosens and the body, relieved of its duties for the night, can finally rest. If you're comfortable, keep your eyes closed and let the scene lift you outward until you hover just far enough to hold Earth in your imagination's hands. Think first, not in numbers, but in touch, the roundness of a smooth stone, the cool curve that fits into your palm. Earth has that softness, at a distance, a glowing marble adrift in velvet. Clouds spool gently over the blue, continents breathe under moving weather, and night gathers in a dark shawl stitched with city lights. Only when the calm has settled do we invite the measures in, as if they were friendly guests arriving with warm bread. The planet's diameter is about 12,800 kilometers, spoken slowly so your mind can walk around it, and its waistline, the equator, is a ribbon of roughly 40,000 kilometers. These are not numbers to conquer, but distances to befriend. Imagine you could lace your shoes and take a path that never leaves the ocean's edge, a perfect shoreline of air called the equator. If you walked a steady pace, no hurry, no race, stopping only to rest your legs and watch the moon, those 40,000 kilometers would become a calendar made of sunsets. Even if you could drive without stopping, a quiet highway wrapped around a world, it would still take you more than 2 weeks at familiar speeds to loop back to where you began. Every hour would carry you through new weathers, new perfumes of rain and dust, new dialects of the sea. The diameter, 12,800 kilometers, is another kind of comfort. Picture slicing the planet cleanly through its center to reveal a simple cross-section, like cutting a fruit to admire its rings. From one side to the other, that wide measure tells you how vast the body really island. If you could somehow walk straight through solid rock and simmering metal, pressing on at a gentle, unhurried pace, months would pass before you reached the far side. The mind cannot take that journey with feet, so it travels instead with metaphor. Imagine a chain of human lives, each one leaving a cairn of memory for the next, until the line of experience itself becomes long enough to cross from crust to core to crust again. Let the scale model help, because models are cradles for the imagination. If Earth were the size of a marble resting in your open palm, you could feel its weight and see it shine. A single fingertip could eclipse an ocean. The ridge of your thumb could hide a mountain range. Your other hand could circle the equator in a single patient sweep. Now step back into the real scale without letting go of that feeling. The planet is so large that mountain ranges barely ruffle it, so broad that airplanes trace tiny stitches in the air and call them routes, so round that ships vanish below the horizon, not because of distance alone, but because the world itself curves away, tucking them gently from view. You might ask how we know these measurements, and the answer is both simple and soothing. We learned by listening to Earth's shape, in many ways, watching shadows at noon in different cities, timing the whisper of satellites, feeling the tug of gravity and the rhythm of orbits. Ancient surveyors once compared the length of a shadow in one place to the length of a shadow far away, and from the difference, they heard the planet's roundness singing. Modern instruments refine the melody, but it is still the same song. A sphere, slightly squashed at the poles, turning steadily, wearing a band of atmosphere that glows blue when sunlight grazes it. Hold for a moment the intimacy of circumference. 40,000 kilometers is not just a number. It is a circle of winds. It carries the trade winds that fill brown sails in old paintings, the jet streams that shepherd storms across maps, the gentle breezes that drag kites over parks on warm evenings. That ribbon also carries migrating birds who memorize invisible highways, and plankton blooms that pulse in satellite images like quiet cosmic nebulae rendered in teal. If distance is a lullaby tonight, circumference is the refrain repeating, returning, assuring us that motion can be a kind of home. Think of the ways we carve that circle into ours. At the equator, the Earth's rotation carries you beneath the stars at about 1,670 kilometers per hour, though you don't feel the rush. You feel gravity's faithful hand, the chair beneath your weight, the slow choreography of shadow sliding across a room. Daylight and darkness take turns not as rivals but as dance partners. If you set a cup of tea near a window and sit with it as the hours drift, you can watch the light change temperature on the wall, honey shifting to amber, then to the cool silver of evening. That changing light is circumference translated into color. Now place your attention on the tender mystery of scale, how the planet can be enormous and intimate at once. 12,800 kilometers is a cathedral of distance, but under your feet, it becomes soil that remembers rain. 40,000 kilometers is a belt of air big enough to host the histories of every language and lullaby. Yet, in the space of a single afternoon, two friends can amble half a dozen city blocks and feel they have crossed an entire era of conversation. Scale does not scold us. It smiles and says that both experiences are true. We are small, and what holds us is grand. We are brief, and what shelters us is old. Let the globe turn once beneath your gaze. Blue coils of ocean carry chains of waves across basins so large that storms are born, live, and fade without ever seeing land. Continents drift like heavy, patient rafts, a few centimeters each year, and yet their collisions lift mountain ranges that catch snow. The polar caps wax and wane, seals breathe below black ice, and auroras lace the night with green veils that ripple like whispered laughter. All of this motion, vast and minute, occurs upon the scaffold of those same two measures, a diameter to house the deep, a circumference to cradle the winds. Before we leave this scale, try one more gentle comparison. Imagine every kilometer as a heartbeat. The diameter becomes a litany of 12,800 soft thuds, the circumference a circle of 40,000 hushed pulses. Counted this way, the planet feels not like a rock, but like a rhythm. It carries us through our days, through our weather, through the tapestry of ordinary miracles, seed to leaf, cloud to rain, story to sleep. Numbers, when rocked slowly like this, become part of the music. When you're ready, set Earth back into its orbit in your mind. Not far, not near, just right. A home-sized star step in a wide, dark room. We will keep these measures as travel snacks for the road ahead, friendly, familiar, never hurried. Soon, we'll lift our eyes toward the hearth that warms this blue world, and let a new measure enter, the space between Earth and Sun, a distance so steady that light itself spends a handful of minutes crossing it, arriving like a warm letter each morning on your skin. For now, take one more breath, and let the numbers dim to a glow, as constant and reassuring as a nightlight left on in a quiet house. Let's open the next door softly without rushing, and invite in a single friendly idea, a new ruler for space. On Earth, we measure our days in footsteps and streets, and the occasional road that threads a horizon. In space, the distances grow so patient, so hushed, that our old rulers feel like toy yardsticks at the edge of an ocean. Astronomers, practical romantics that they are, chose a measure based on something we know by heart, the path from us to our hearth. They call it an astronomical unit, the average distance from Earth to the Sunday, 1 AU. Not a mountain of digits tumbling out of a calculator, but a home-sized stride in the darkness. If you prefer numbers served warm, the AU is roughly 150 million kilometers. Let that sentence breathe. You don't have to hold the whole number at once. Just touch it and set it down, like a smooth stone turned in the hand and returned to the shore. The sunlight that reaches your window in the morning began its journey a little over 8 minutes earlier, about the length of a kettle's soft murmur, or a song that you let play to the end even after the dishes are done. Every golden square of light on your floor is a recent traveler. It is not ancient, not remote, but freshly delivered across an AU of quiet. Light, the universe's swiftest messenger, spends those 8 minutes crossing the dark between our world and its star at nearly 300,000 kilometers each second. Numbers blur at that speed, so trade them for a picture. Imagine the sun as a bright fireplace at the far end of a peaceful hall, and Earth, a chair drawn up at a comfortable distance. Throw a sparklight and watch it drift with perfect steadiness. Before you've finished a slow breath, the spark arrives and warms your hands. This is the scale of our days, the tempo of mornings, the soft drum that keeps time for weather and seasons. But imagination appreciates something it can hold, so let's cradle the AU in a pocket-sized model. We'll shrink Earth to the size of a marble, smooth and cool, something you could keep in your palm and turn with your thumb as you listen. At this scale, the sun becomes a bright beach ball, the kind you might see drowsing in the shade at a summer picnic. Place that beach ball on the ground, and then step back farther, until you are about 26 meters away. That length of space, the easy width of a swimming pool or a hallway repeated several times, is our shrunken AU. Suddenly, the solar backyard feels understandable. You can stand in it. You can point to it. You can pace it out in an evening stroll. Notice what happens when distance is given texture. 26 meters isn't an abstraction. It's the way your voice changes timbre when you call to a friend from across a small field. It's the number of strides it takes to cross a quiet gym at night and listen to your footsteps bloom into echoes. At that scale, sunlight's 8-minute journey becomes a tender comparison. In our marble and beach ball world, the light would cross those 26 meters in a heartbeat, so small you'd miss it if you blinked. In the real sky, the heartbeat is longer, more luxurious 2 or 3 songs long, because the true hallway between Earth and Sun is immense. The model is not the thing, but it is a lullaby that holds the rhythm. Walk with me through this miniature. You, holding Earth the marble. There, ahead, the beach ball sun glowing in your mind's eye. The space between is not empty. It is a room filled with invisible threads, gravity's hush, magnetic whispers, the slow dance of particle winds. If we placed a second marble in this model for the moon, you could keep it just over a thumb's breadth from Earth. The nearness would surprise you. Most of us carry the moon in our thoughts as something far, but in the scale of the solar family, Earth and moon are close enough to speak in murmurs and hear each other clearly. The AU gives us that feeling, closeness and vastness braided together, both true. Why do astronomers favor this unit? Because it turns the solar system into a story we can remember. Mercury lives at about 1/3 of an AU from the hearth, close enough to feel a constant blaze. Venus glides at a comfortable 2/3 to 3/4 of an AU, a brilliant evening guest with a complicated interior life. We keep our easy seat at 1 AU, where oceans can remain oceans and rain can find its way back to rivers. Mars wanders a little farther, beyond the 1.5 AU mark, where cold breathes a little heavier on bare rock. With the AU, we aren't juggling columns of digits. We're setting placemats around a table and learning the family by their chairs. The 8-minute letter of light we receive from the sun also helps us think about time as a gentle dimension of distance. When you stand in a sunbeam, you are greeting the recent past, a postcard that left the star moments ago with a note that reads, "All is well here, warmth enclosed." The AU multiplies into time naturally. 2 AU, 16 and some minutes for light to make the round trip. 10 AU, a span long enough for the kettle to whistle, the tea to steep, and a quiet page or two to turn. Without hurrying, the AU teaches patience. Let's let curiosity play a little game. Suppose you placed Earth, the marble back in your pocket, and began a slow walk around the beach ball sun, keeping 26 meters of respectful space. 1 circle is a year. You might stop at 4 points on the compass and watch the light change color across your open palm. In one position, your hand feels gently tilted toward the warmth, and the imagined day is long. In the opposite position, your hand tilts away, and evening arrives early. Seasons, with all their fragrances and rituals, emerge from that mild lean as you keep your constant distance. The AU is the steady heartbeat. The tilt is the breath between beats. You may feel a question rise. If 1 AU is already so large, what happens when we look beyond, when we measure the solar system's breadth or the gap to the next star? The AU is our first rung on a ladder that climbs into awe. Soon, we will need a longer measure, something made of light and years. But staying here for a moment is a gift. 1 AU is enough to hold sunlight's travel time and the shape of a year in the same gentle bowl. It lets us feel held. Not too close to burn, not too far to freeze, but balanced the way a lantern is hung, at the right height to read by. Before we go, listen for the other music the AU plays. Engineers hear it in trajectories, arcs of spacecraft that skim and sling, using gravity like a hand over a banister. Gardeners hear it in the way spring steps over thresholds at different latitudes, following the light's patient geometry. Children hear it without words, when they tilt their faces into a warm square on the floor and forget the clock. The AU is a measure, yes, but it is also a mood, the calm assurance that morning will arrive on time. because the distance is just so, and because the dark between is a faithful carrier of light. Now, take one more slow breath and let your inner model dim to a glow. Beach ball, sun resting quiet, marble earth tucked safe, 26 meters of friendly space humming with invisible threads. We'll keep the AU in our pocket as a comfort and a compass. In the next hush, we'll begin to pace the wider room, the long promenades where even AUs begin to feel small, and we'll invite a grander measure to the table, the light year, a lullaby counted not in steps, but in years of starlight. For now, rest your hands together, feel the warmth they hold, and remember, every morning's light is only 8 unhurried minutes away. Let's stay with our pocket model a moment longer, because it's a kind teacher. The beach ball sun naps at one end of the field. The marble earth keeps its respectful 26 meters. Now let your mind set the rest of the family down, softly, in widening circles. Mercury first, close to the hearth so near that a single step or two would bring your shoes warm. Venus next, bright and veiled, between you and the sun like a lantern wrapped in silk. Then our own orbit, where oceans shiver into rain and back again. Beyond us, Mars, its path just a little farther out in the cool. Each new circle feels like a breath taken slightly deeper than the one before. But the promenade doesn't stop at the familiar. Carry your steps outward, past the bright paths of the inner planets, into the room where giants linger. In our scale, Jupiter would not be an apple. It would be a heavy grapefruit, rolling slowly along a track, 2.5 AUs from our seat, around 65 meters from the beach ball Sunday. Saturn, ringed and serene, glides at about double that again, its ring plane a pale, impossible halo you could not help but pause to admire. Farther still, Uranus and Neptune cold, calm lanterns in the deep. In the true sky, these worlds are worlds, but here in the quiet of imagination they become gentle markers, evenly spaced notes in a lullaby that keeps expanding. And then comes a threshold you can feel rather than see. Beyond Neptune's careful blue lies a wide, dim garden, the Kuiper Belt. Think of it as a hush after conversation, a place where the sun's voice grows softer and objects small and ancient keep to their slow, elliptical routes. Here, drift thousands of icy bodies leftovers from the kitchen where the planets were baked everything from pebbled fragments to dwarf worlds with moons of their own. Pluto lives here, not banished, not diminished, just properly introduced. It is a modest monarch, carrying a heart-shaped plain of nitrogen ice across its surface and circling our star on a long, tilted path that sometimes brings it closer than Neptune, sometimes farther. In our marble and beach ball world, Pluto would be another bead, and the distance to it would surprise you, nearly a full kilometer from the Sunday. Walk that length in the evening light past goalposts, past benches, past the line where the field becomes the parking lot, and only then set Pluto down. Turn around, and the beach ball sun is a fond memory across the grounds. Notice how the spaces widen. The solar system is not a tightly packed necklace, but a poem with long, gentle pauses. Between orbits, there is room for silence and starlight to settle. The Kuiper Belt itself is not a thin ring, but a fat, soft band, like frost feathered across a window. Many of its residents are name quiet, their faces unphotographed, their histories written in slow rhyme. Here, too, comets sleep like seeds in a winter bed, waiting for a nudge, a passing star's distant tug, or the faint tides of our galaxy to draw them inward, where the sun can warm them into brief, bright tales. Even beyond this icy garden, the family continues. The sun breathes, and its breath becomes wind streams of charged particles that flow outward in every direction. This solar wind carves a vast bubble in the thin interstellar medium, a homey boundary called the heliosphere. Imagine the beach ball sun exhaling a sphere so large that, even shrunk to our model, it would swell past the track where Neptune glides, past the Kuiper Belt's crowded hush, nearly to that kilometer mark and beyond. At the heliopause, the bubble's skin, the wind finally yields to the winds of other stars, the interstellar breeze. It is not an edge like a cliff. It is a blending, like dusk. Two small, brave emissaries have reached this dimmer room. The Voyager spacecraft, launched when many of us were children or not yet born, drift onward with a patience only machines and stars possess. They have tasted the boundary, felt the change in particle music, and kept going. Signals from them arrive at Earth as whispers that have traveled for more hours than a day can comfortably hold. If you could make your radio heartbeat slow enough, you could hear the distance. If you could wrap your ear around the sky, you could hear the soft applause of our star's breath against the universe's wider air. But the solar system is larger still, so much larger that the AU, our friendly stride, begins to look small again. Around our star, across a span that dwarfs the Kuiper Belt and the heliosphere both, extends a great possible sphere of icy relics, the Oort cloud. Picture a snow globe, not packed with flakes, but with crystal seeds, each asleep on an orbit so long that it measures itself in the language of civilizations rather than seasons. The inner reaches may begin a few thousand AUs from the Sun. The outer could drift toward 100,000 AUs. Those numbers are gentle mountains. In kilometers, they swell to around 15 trillion, and in our model they would scatter their beads so far into town that you'd need a map and a good pair of shoes to find the edge. The Oort cloud is not a place you visit. It is a weather of distance, a possibility that holds the long memory of our star's formation, how neighboring suns nudged and sculpted, how the young solar system inhaled and exhaled material until the farthest seeds were thrown into this almost imaginary shell. Why speak of such enormity at bedtime? Because it changes the texture of thought. When you learn that Pluto's marble sits a kilometer from the beach ball sun, and that the cloud beyond may be 100 times farther still, something in the mind relaxes, the way shoulders drop when a room goes quiet. You realize that most of space is space room enough for patience to take its time, for light to write long letters, for a comet to practice its ellipse for 10,000 years without anyone hurrying it along. The solar system is not crowded. It is generous. Return for a moment to the idea of sunlight as mail. At Earth, letters arrive in a little over 8 minutes. At Jupiter, they need 43. Saturn receives them in about an hour and 20. Neptune waits over 4 hours for each envelope of warmth to cross the dark. At Pluto's average distance, a single delivery may take between 5 and 6 hours. Imagine the rhythm of those postmarks, how dawn in the deep grows from a slower post, how shadows lengthen with a patience that would make any clock yawn. And yet, the letters do arrive. The beach ball sun never forgets a friend's address. If you listen closely, you can also hear gravity humming through this whole arrangement, the way a plucked string vibrates through wood. Gravity is the soft insistence that keeps each world to its path. It is not a command, it is a lullaby. Within its music, planetary resonances form Jupiter and Saturn, keeping time in a way that nudges asteroids into safe orbits, or sends them, rarely, into new adventures. In the Kuiper Belt, resonances with Neptune shepherd small bodies into families with names as old as myths. In the Oort cloud, gravity's voice is softer, a far-off choir that only occasionally raises a comet to singing. Sometimes people ask where the solar system ends. The truth has edges that are more like atmospheres than fences. The heliosphere is an edge of wind. The Kuiper Belt is an edge of debris. The Oort cloud is an edge of memory, a border made of seeds waiting for spring. Beyond all of them lies interstellar space, which is not empty so much as exquisitely sparse, a vast, cool hallway connecting every star to every other. By any definition, our home's reach is longer than our first rulers can easily hold. This is why, as we leave the wide yard of our own star and lift our gaze to the neighbors, astronomers adopt a new measure, a measure made of light and patience that can cradle the distances between suns, as simply as the AU cradles the distance between Earth and ours. The light year waits just ahead, like a footbridge into the next garden. Before we step onto it, take one more breath and picture the scene we're leaving. The beach ball's sun warm against the grass, a glitter of orbits widening into quiet, the Kuiper belt's frosted hush, the great, imagined shell of the Oort cloud, like a snow globe set upon the lap of the night. In this stillness, in this vastness, it is perfectly safe to close your eyes. We will open them again among the stars. Beyond the Kuiper belt's frosted silence and the imagined shell of the Oort cloud, our old unit of measure, the astronomical unit, begins to feel like a tiny coin dropped into an endless well. To take the next step, astronomers offer us a gentler companion, the light year. It is not built of kilometers, not even of AUs, stacked like bricks, but of time itself, the distance light travels in 1 year. Nearly 9.5 trillion kilometers, or about 63,000 AUs, folded into a single word. A light year is easier to carry than its numbers. Instead of juggling trillions, we imagine light a messenger, swift and constant, stretching its stride across the darkness. Each second it travels 300 kilometers. Each day it sails nearly 26 billion. Each year it threads nearly 5 trillion. If you prefer, you can think of it as footsteps, 1 year's worth of them, each step as fast as anything in the universe can move. The light year is the lullaby we hum when distances grow too vast for our ordinary rulers. With this new measure in hand, let's turn to our nearest neighbor beyond the Sunday Proxima Centauri. A small red star in the Alpha Centauri system lives about 4.2 light-years away. At first, that sounds modest, a single digit, a short number. But step inside the scale, and you'll see how far it really island. In our marble and beach ball model, Earth still a marble and the Sun a glowing sphere 26 meters away, Proxima Centauri would be another beach ball placed more than 7,000 kilometers from the first. That's roughly the distance from New York to Tokyo, or from London to the heart of the Pacific. One marble here, one beach ball there, and between them an ocean of emptiness so wide that 1 trillion more marbles could fit without touching. The gulf between stars is not crowded, but sparse. Even in the densest neighborhoods of our galaxy, stars live far enough apart that entire solar systems, planets, moons, comets, can exist for billions of years without brushing against another. If you stepped out into interstellar space and looked around, you would find yourself in a night even quieter than our own sky, where the nearest hearth is years of light away. And yet, Proxima's light still arrives. Faint, red, but steady. Each photon crossing 42 trillion kilometers to finally touch your eye is a reminder that the void, however empty, can still carry messages. When you let this distance sink in, you begin to feel the nature of scale in the cosmos. Light years are not designed to overwhelm but to comfort. They whisper, take it 1 year at a time. Proxima's 4.2 mean 4 winters, 4 summers, 4 cycles of leaves or rains stacked side by side. Stretch them long enough, and you've crossed the hallway to another Sunday. Measured in human lifetimes, the number grows heavier. Tens of thousands of generations of travelers would be needed to walk it with rockets at our current speed. But measured in starlight, the path is continuous, no interruptions, a single beam bridging the abyss. And so the light year is more than a ruler. It is a rhythm, a way to hear the galaxy's heartbeat. Stars we see tonight may be sending us light that left when mammoths walked, when glaciers carved valleys, when civilizations were only dreams. The universe writes its autobiography in light years, and when we read them slowly, they feel like chapters in a long, gentle story. In the next step, we'll widen our gaze from the nearest neighbor to the great river of stars around us, the Milky Way itself, and use our new ruler to understand how many light years it takes to cross the spiral arms of our home. But for now, let the idea of 4.2 light years rest in your mind. Imagine holding that beam of Proxima's light in your hand, a postcard written 4 years ago that finally found you tonight. From Proxima's faint glow, let's widen the lens again outward, into the river of stars that makes our sky look dusted with milk. This is the Milky Way, our galactic home. For many cultures, it has been called a path, a bridge, a river, a scattering of flower across the heavens. Whatever the name, the truth is both simpler and greater. It is our vantage of the disk of stars we live inside, seen from the inside out. The size of our galactic home. The Milky Way stretches about 100 light-years across. Already, the light year we just met earns its keep. 100,000 of them, set edge to edge, trace the wide, flat disk where hundreds of billions of stars make their lives. From top to bottom, the galaxy is thinner about 10 light-years thick in the disk itself. Compared to its breadth, it is a cosmic pancake, delicate and luminous. When you imagine this, pause. Even though we use words like disk or spiral, the galaxy is not a neat drawing but a storm of suns, dust and gas, shaped over billions of years by gravity's patient hand. Still, a spiral is close enough. 2 main arms and several smaller spurs, like brushstrokes curving from a bright central hub. Our address, a suburban spur. We live not in the hub, not in the crowded downtown of stars, but in a quieter lane called the Orion Arm, or local spur. It's a minor offshoot tucked between 2 of the galaxy's larger spiral arms. Here, about 26 light-years from the center, our sun drifts along with its planets, moons, comets, and us tenants of a suburb in a luminous city. The distance matters, not just as a number, but as a feeling. The galactic center is bright, crowded, tumultuous, full of ancient stars orbiting a supermassive black hole. Our seat in the suburbs gives us balance, not too close to the chaos, not so far that we drift in empty outskirts, just right. A safe distance to evolve oceans, forests, stories, and lullabies. Billions of stars, billions of stories. Astronomers estimate the Milky Way carries 200 to 400 billion stars. The range itself is soothing. It tells us we cannot count them all exactly, but we can live with an estimate. Each star, large or small, is a hearth with its own company of planets, asteroids, and icy wanderers. Some are suns like ours, most are smaller, redder, dimmer. A few are giants so large they could swallow Earth's orbit whole. Together they make a community too vast to imagine fully, yet soft enough to see as a band across the summer sky. When you tilt your head back on a clear night and see the Milky Way stretching overhead, you are looking through the thickness of the disk into layers upon layers of suns. Each pinprick is an individual flame, but together they become a river of light. Time and travel in the galaxy. Even light takes patience here. To travel from one edge of the Milky Way to the other would require 100 years, even at light speed. Human history, from its first campfires to our telescopes, is less than 1% of a single crossing. We are very new, standing on a balcony, just beginning to notice how far the street runs. This scale is not meant to exhaust you, but to calm you. In a galaxy that measures itself in hundreds of thousands of light-years, our days shrink into moments, our years into sparks. And in that shrinking, our troubles become lighter, easier to set down, easier to release into the dark, where stars have been waiting far longer than us. In the next step, we'll slow down inside this spiral city and visit its architecture, the central bulge, the spiral arms, the hidden halo that wraps around it all, and the unseen matter that keeps the galaxy whole. For tonight, let your mind hold just one picture: the Milky Way as a great wheel of light, 100,000 light-years wide, and you a small, bright thought, resting safely in one of its arms. Close your eyes a moment longer and picture our galactic home not as a static disk, but as a living city of stars with distinct neighborhoods. The Milky Way is not just wide and luminous. It has architecture, patterns that whisper its history. The central bulge, a luminous heart. At the center of the galaxy swells a bulge, a dense sphere of stars packed so tightly that their light overlaps into a golden haze. These are older suns, ancient elders that have been shining since near the dawn of the Milky Way itself. Hidden in the very core lies a supermassive black hole, known as Sagittarius A. It weighs millions of times the mass of our Sun, yet it rests in silence, shaping orbits with gravity's hand. Around it, stars orbit in dizzying years measured in mere decades, compared to the Sun's hundreds of millions. The spiral arms, highways of starlight. From the bulge stretch the spiral arms, sweeping curves of gas, dust, and newborn stars. They are not rigid structures but waves, like traffic jams of light. Stars move in and out of them, yet the arms endure. Within them, clouds of gas collapse to form clusters of stars, illuminating the spiral like glowing neighborhoods lit at night. The Orion Arm, where we live, is one such spur, a quieter district compared to the bustling grand arms, yet vibrant enough to nurture life. The disk, a thin, shimmering plane. The galaxy's disk itself is thin, only about 10 light-years tall compared to its 100 light-year diameter. Within this slender layer lies almost all the Milky Way's starry population, its gas clouds, its nurseries, and its storms of dust. Seen from outside, the disk would glow like a misty coin of light, rimmed with faint wisps, where gas drifts into the surrounding dark. The halo, a ghostly sphere. Surrounding this disk is a halo, vast and faint. It contains old stars and globular clusters, dense, ancient knots of thousands or millions of suns, each orbiting like bees in a hive. The halo extends far beyond the visible disk, perhaps 200 light-years across, enveloping our galaxy in an almost invisible sphere. The dark matter frame, and beyond all this, unseen but real, lies the dark matter halo. Astronomers know it must exist because the stars at the galaxy's edges orbit faster than they should. Something invisible matter that does not shine provides the gravity to hold them in. This hidden frame is several times more massive than all the stars, gas, and dust combined. It is the silent scaffolding that makes the Milky Way possible. A city alive with time. Together, the bulge, arms, disk, halo, and dark matter weave a living structure. The Milky Way is not frozen. It rotates, evolves, collides with smaller galaxies, and will one day merge with Andromeda. Each component tells a part of the story. The bulge speaks of the past. The arms glow with the present. The halo carries memories of long-ago mergers, and the dark matter, though unseen, ensures the story continues. In the next step, we will journey into the Milky Way's nurseries, where stars are born in clouds of gas and dust, and where the story of light begins anew. For now, let the picture rest. A spiral city of stars with a glowing heart, curving arms, a thin shining disk, an ancient halo, and an invisible frame, our cosmic address in the great night. The Milky Way's neighborhoods unfold like districts in a great glowing city, each with its own mood and rhythm. At the heart of the city, the central bulge glows like a lantern in the night, dense, ancient stars burning in golden light, clustered so tightly their radiance blends together. Hidden at its very center rests Sagittarius A, a supermassive black hole whose invisible pull keeps the galactic city anchored, like a silent fountain at the center of a cosmic square. From this luminous hub spiral out the arms, graceful boulevards of starlight. They curve through space like rivers lined with lanterns, each arm carrying billions of suns and clouds of gas where new stars are born. The Orion Arm, our own cosmic neighborhood, is just a quiet side street. Yet even here, the starlight is rich enough to give rise to planets, oceans, forests, and life itself. Stretching outward, the disk forms the wide plaza of the city, thin compared to its width, yet shimmering with 100 billion stars. If you could rise above it, the view would be like gazing upon a glowing coin floating in the dark, its surface textured with dust lanes, star clusters, and glowing nebulae. Beyond, the halo extends like a ghostly park encircling the city. Faint and nearly invisible, it holds ancient star clusters, fossils from the galaxy's childhood, still orbiting like lanterns from another age. Encasing it all is the unseen dark matter frame, the silent architecture holding everything together. Though invisible, it is the true foundation, the quiet scaffolding that makes the galaxy's grandeur possible. As you drift through this picture, remember, our home is not just a flat disk of stars, but a layered, breathing structure, evolving with time. Its arms and bulge, its halo and hidden frame, all whisper stories of creation, destruction, and renewal. And now, with the architecture of the Milky Way in mind, let us wander deeper into its nurseries of light, where stars are born in clouds of gas and dust, glowing like cradles in the cosmic night. Within the Milky Way's sweeping arms lie places unlike any earthly landscape stellar nurseries, vast clouds of gas and dust, where stars are slowly kindled into being. Imagine drifting through them, immense curtains of vapor glowing faintly, streaked with darker filaments where light cannot escape. These clouds are cold and quiet at first, but within them gravity begins its patient work, pulling atoms together until they collapse under their own weight. In time, knots form dense pockets, where hydrogen gathers more tightly than anywhere else. As the collapse continues, the pressure rises, and the temperature climbs. Deep inside these pockets, like sparks inside kindling, nuclear fusion ignites. The cloud gives birth to a star. What was once invisible gas becomes a radiant point of light, shining for billions of years. You may have seen the most famous of these nurseries in photographs. The pillars of creation inside the Eagle Nebula, towering structures of dust and gas, each taller than our entire solar system, loom like cosmic cathedrals. At their tips, new stars are forming, their light just beginning to seep out, eroding the clouds that sheltered them. The Orion Nebula, closer to us, glows as a nearby example, a stellar cradle visible even through small backyard telescopes. In these nurseries, stars are not born alone. They come in clusters, siblings sharing the same cloud, often flung apart later by gravity's dance. Some are massive and bright, burning hot but living short lives. Others, like our sun, shine more gently, offering billions of years of steady warmth. Around them, the leftover gas and dust flatten into disks, where planets, moons, and comets may form. In time, some of those planets may grow oceans and skies, forests and rivers, perhaps even creatures who look up and wonder. Think of it: the calcium in your bones, the oxygen you breathe, the iron in your blood. Each atom was once part of a star's story. The nurseries of the Milky Way are not distant curiosities. They are our ancestral homes. Every heartbeat carries the memory of stellar birth, every breath a reminder that we are woven from the light of forgotten clouds. As we linger in this thought, let the image settle. Colossal clouds adrift in the spiral arms, glowing softly in colors of pink, blue, and violet, nurturing new suns that will shine long after we are gone. In these quiet forges, the galaxy renews itself, one star at a time. In our next step, we'll follow those massive stars as they live their brief, brilliant lives and end in explosive finales that reshape the Milky Way's story. When stars are born in those glowing nurseries, their futures are written not in decades or centuries, but in millions and billions of years. Yet not all stars live the same way. Some burn gently, like our sun, offering long, steady warmth. Others blaze with intensity, racing through their fuel until their lives end in breathtaking finales. The short, brilliant lives of giant stars. Imagine a star many times the mass of the Sunday. It shines so brightly that its energy pours out into space with furious speed. These massive stars live fast and die young, often in only a few million years, a blink compared to the sun's 10 billion-year lifespan. Their light is blue and fierce, flooding their regions of space like floodlights on a cosmic stage. But such brilliance cannot last. Their gravity battles their inner fire until, at last, the star can no longer hold itself together. Then comes one of the most powerful events in the universe, a supernova. Supernovae, the cosmic fireworks. In a single moment, a star collapses and explodes outward, releasing more energy than our sun will in its entire life. For weeks, the star shines so brightly it can outshine entire galaxies. Its shockwaves tear through the surrounding space, sculpting new clouds and sometimes sparking the birth of other stars. These explosions do more than dazzle, they seed the galaxy with heavy elements. Gold, iron, oxygen, carbon, all forged in the heart of stars and scattered across space by their violent deaths. Without supernovae, there would be no rocky planets, no oceans, no breath, no life. Stellar remnants, ghosts of giants. After the fireworks, something remains. Sometimes it is a neutron star, a city-sized ball of matter so dense that a teaspoon of it would weigh as much as a mountain. Sometimes, if the star was massive enough, it collapses further, becoming a black hole, a well so deep in space and time that not even light can escape. These remnants are like monuments, reminders of lives lived in fire. They continue to shape the galaxy long after their parent stars have faded, bending space, radiating energy, and occasionally colliding in events that ripple through spacetime itself. Renewal through destruction. Though violent, these endings are also beginnings. The shockwaves stir nearby clouds, compressing them and triggering the next cycle of star birth. In this way, the Milky Way renews itself through destruction, turning death into the raw material for new generations. As you rest with this thought, let it soothe you. Even in endings, the cosmos writes beginnings. In the next step, we'll explore how these cycles birth, life, death, create the rhythm of the Milky Way, a rhythm that has continued for over 13 billion years. The Milky Way has its own rhythm, slow, patient, yet always in motion. Birth and death of stars, collapse and explosion, creation and renewal each plays like a note in a symphony that has been unfolding for over 13 billion years. A galaxy in motion. Though it looks still when we gaze at the night sky, the Milky Way is a dancer. The entire disk rotates, though not as a solid wheel. Inner regions orbit faster than the outer edges, winding the spiral arms into their graceful curves. Our own solar system takes about 225 million years to complete a single circuit around the galactic center, a galactic year. In Earth's lifetime, we have completed only about 20 such journeys. When dinosaurs roamed, our planet was on the opposite side of the galaxy, the flow of matter and energy. The galaxy is like a breathing organism. Gas flows inward from intergalactic space, feeding new generations of stars. Supernovae send shockwaves outward, enriching the medium with heavy elements. Hot winds rise above the disk into the halo, then rain back down like a fountain. Each flow sustains the balance, keeping the Milky Way alive. Cycles of renewal. Massive stars blaze and die quickly, scattering their elements like seeds. Smaller stars burn for billions of years, their steady light nurturing stability. Star clusters form, dissolve, and spread their members across the arms. Globular clusters orbit like ancient guardians, while dark matter provides the invisible rhythm that keeps all motions bound. Through these cycles, the galaxy is both ancient and forever young. Parts of it hold stars older than Earth, while others are nurseries still glowing with new light. The Milky Way is a record of time itself, every region preserving a chapter in the story of cosmic evolution. The comfort of continuity. As you drift with these thoughts, imagine the galaxy's breath slow, eternal, never hurried. In the quiet of your evening, your own breath matches its rhythm. Inhale and think of stars collapsing into light. Exhale and imagine new clouds forming, waiting for their turn. You are part of this cycle too, every atom in your body born from an earlier generation of stars. In the next step, We will leave the broad sweep of the Milky Way's rhythms and travel toward its ancient core to explore what lies hidden in the crowded heart of our galaxy. Deep in the galaxy's heart lies a region unlike anywhere else, the galactic core, crowded, brilliant, and mysterious. If the Milky Way were a living city, this would be its bustling downtown, where every block is filled with dazzling lights and hidden forces, a golden glow of ancient stars. The galactic bulge shines with the light of billions of old stars. Their combined glow creates a golden haze so bright that, if we could strip away the veils of dust, it would outshine the rest of the galaxy. These stars are veterans, ancient suns, that have endured since the galaxy's youth, still circling faithfully around the core. Sagittarius A, the silent giant. At the very center rests Sagittarius A, a supermassive black hole with the mass of more than 4 million suns. Though invisible, its gravity shapes the dance of everything nearby. Stars whip around it in dizzying orbits, completing revolutions in just a handful of years, racing at speeds that defy imagination. Sometimes, a cloud of gas drifts too close and flares with X-rays as it falls into the abyss. Other times, stars are torn apart, their remnants spiraling inward in luminous arcs of plasma. The challenge of seeing the core. From Earth, we cannot see the center with ordinary eyes. Clouds of dust and gas in the galactic disk block visible light. But with infrared and radio telescopes, astronomers pierce the darkness, revealing a crowded realm where stars orbit in tight knots, and where the laws of physics bend under the immense pull of gravity. A place of extremes. Here, the environment is unlike anywhere else in the Milky Way. Stars are denser, radiation more intense, gravity stronger. Yet even in this extreme region, life's raw materials swirl gas, dust, and energy interacting in ways we are only beginning to understand. The galactic center is not just a place of mystery. It is a reminder of how the galaxy is bound together. Its heart beats quietly, hidden behind dust, shaping the spiral arms and anchoring our cosmic home. In the next step, we will journey outward again, leaving the crowded core for the spiral arms and their flowing rivers of starlight, where much of the galaxy's everyday life unfolds. From the crowded heart of the Milky Way, let us drift outward again, into the sweeping spiral arms, where most of the galaxy's visible beauty resides. If the core is its golden lantern, the arms are its glowing rivers, curved highways of gas, dust, and stars winding through space in delicate arcs. Rivers of starlight. The Milky Way's spiral arms are not solid structures but waves of density, like slow-moving traffic jams in the galaxy's rotation. Stars, clouds, and gas flow into these regions, compress, and then drift onward again, yet the arms endure. They appear permanent, though they are patterns in motion, rivers of starlight that only exist because of gravity's rhythm, birthplaces of stars. These arms are where the galaxy renews itself. Gas clouds enter, compress, and collapse into new suns. Within the Orion Arm, our quiet spur, lies the Orion Nebula, a stellar nursery visible with the naked eye on dark nights. Elsewhere, the Sagittarius Arm blazes with young, massive stars, their light so fierce that they outshine their surroundings, while the Perseus Arm curves like a grand boulevard filled with clusters, nebulae, and streams of glowing hydrogen. A neighborhood called home, our solar system's address, places us within the Orion Arm, a minor spur between the larger Sagittarius and Perseus Arms. This quiet location may be why life had time to flourish here. Far from the chaos of the galactic center, yet close enough to the richness of star formation, Earth finds itself in a cosmic suburb, neither too crowded nor too empty. A living spiral. Seen from above, the Milky Way would look like a giant pinwheel of light, with its arms stretching more than 100 light-years across. Each arm is alive with starbirth, supernovae, and drifting clusters, shaping the galaxy's ongoing story. If the Milky Way were frozen in time, its arms would look like delicate brushstrokes on a canvas. But in truth, they are more like waves in the sea, always moving, always reshaping. As you rest with this image, imagine yourself looking down from far above, a spiral city of stars, glowing against the dark, arms curving outward like cosmic rivers. In our next step, we will travel further still out of the disk and into the halo, where ancient clusters and hidden mysteries drift quietly in the darkness. Beyond the bright arms of the Milky Way lies a quieter, older realm, the galactic halo, a vast and ghostly sphere that surrounds the disk like a faint aura. Though it holds fewer visible stars, it carries some of the galaxy's deepest secrets. Ancient star clusters. Scattered throughout the halo are globular clusters, dense, spherical collections of hundreds of thousands of stars. These are some of the oldest residents of the Milky Way, shining for more than 12 billion years. Their stars are poor in heavy elements, meaning they formed before many supernovae had enriched the galaxy. Looking at them is like peering into a fossilized memory of the Milky Way's childhood. Each cluster orbits in long, looping paths, passing above and below the galactic disk. To an observer within, the night sky would blaze with thousands of stars packed so closely that the heavens would never truly grow dark. The faint halo of stars. The halo itself contains scattered, ancient stars, lonely wanderers drifting on eccentric orbits. Some may not even be native. Instead, they are immigrants from smaller galaxies the Milky Way consumed long ago, their paths tracing the scars of ancient mergers. Streams of history. Indeed, the halo is filled with stellar streams, long rivers of stars stretched across the sky, torn from dwarf galaxies captured by our own. Each stream is a ghostly reminder of past collisions, the Milky Way's way of growing by absorbing its neighbors. These ribbons of light are maps of our galaxy's violent past. The invisible skeleton. Beyond the stars and clusters, the halo extends into the unseen. Astronomers know that dark matter, an invisible substance, fills this region, forming a framework that holds the galaxy together. Without it, the Milky Way's outer stars would simply drift away. Though unseen, this dark halo is far larger than the galaxy's visible disk, stretching perhaps 300 light-years from the center, giving our home an invisible skeleton. A quiet vastness. The halo is silent, sparse, and dim, yet essential. It preserves the galaxy's oldest stars, records its ancient mergers, and carries the unseen matter that grants the Milky Way its stability. To imagine it is to picture a vast, translucent sphere, encasing the bright spiral within, whispering reminders of both the galaxy's youth and its hidden foundations. In the next step, we'll look at the mass and weight of the Milky Way, numbers so immense they challenge our imagination, yet reveal just how much matter and mystery lies in our galactic home. The Milky Way's true weight is not measured in anything we can hold or balance. It is counted in suns, hundreds of billions of them, and in matter both seen and unseen. Astronomers estimate that our galaxy contains somewhere between 800 billion and 1.5 trillion times the mass of the Sunday numbers, so immense that they stretch the imagination. Counting the stars. Our galaxy is home to 400 billion stars, each one a sun with its own possible family of planets. The smallest of these stars may weigh only a fraction of the sun, while the giants tip the scales dozens of times heavier. Together, they form a stellar population whose combined mass is astonishing, but still only part of the Milky Way's heft. Gas, dust, and the hidden majority. Between the stars drifts an ocean of gas and dust, hydrogen clouds, nebulae, and the raw ingredients for future suns. These account for a significant portion of the galaxy's visible matter. But even when all the stars, planets, gas, and dust are added together, they tell only part of the story. The greater share of the Milky Way's weight lies in dark matter. Though invisible, its gravity betrays its presence. Stars at the edge of the galaxy orbit faster than they should, as if held by a hidden hand. This unseen substance outweighs all visible matter, making up the majority of the Milky Way's true mass. Numbers, beyond comprehension. The Sun alone weighs about 2 times 10 QZ kilograms, a 2 followed by 30 zeros. Multiply that by hundreds of billions, and the numbers swell beyond anything our minds can picture. To write the galaxy's full mass on paper would take lines upon lines of digits, each one adding another layer of incomprehensibility. Astronomers often compare this to simpler images. If every grain of sand on every beach on Earth represented a kilogram, the Milky Way would still weigh more than the total. If you tried to walk across the digits of its mass, each step a number, you could walk forever without reaching the end. The comfort of scale. Yet there is comfort in these incomprehensible numbers. They remind us that our galaxy is vast enough to endure, massive enough to hold together across billions of years, and generous enough to scatter starlight through every arm. To live within such a structure is to rest in a cradle of unimaginable strength. In the next step, we will look not only at the Milky Way's weight, but at its age, a timescale so ancient it stretches nearly to the beginning of the universe itself. The Milky Way does not just carry great weight, it carries great age, stretching back almost to the universe's own beginning. To rest inside it is to rest within something older than mountains, older than oceans, older even than Earth itself. Born from cosmic dawn, astronomers believe the Milky Way began forming about 13.6 billion years ago, less than 200 million years after the Big Bang. In that era, the cosmos was still young, filled mostly with hydrogen and helium, the simplest of elements. From this primordial fog, clouds collapsed, merging into the first stars and clusters. Over time, these early fragments gathered, pulling into larger structures, until the galaxy we know today began to take shape. The ancient stars. Evidence of this ancient past lingers in the oldest stars, still shining in the halo and globular clusters. Some of them are nearly as old as the universe itself, their chemistry reflecting a time before heavier elements existed. When we study them, we are peering not just into their light, but into the fossil record of creation, a galaxy in evolution. For billions of years, the Milky Way grew through mergers and collisions. Smaller galaxies were pulled in and absorbed. Their stars stretched into streams that still lace the halo. Each merger enriched the Milky Way, adding new populations of stars and altering its shape. Our galaxy is not a finished object, but an evolving one, sculpted across time by the quiet persistence of gravity. Age in perspective. Earth itself is about 4.6 billion years old, only a third of the galaxy's lifetime. Human history, even all of civilization, is a breath compared to the span of galactic time. The galaxy has rotated perhaps 20 times since our world first formed. When dinosaurs walked, the Milky Way was already 10 billion years old. The comfort of ancientness. There is something soothing in this thought. We live inside a structure that has endured almost as long as the universe itself. It has seen stars born, flare, and die countless times. It has carried generations of worlds, long vanished, and it will carry many more. Its age is not a weight, but a promise that the rhythms of creation and renewal continue far beyond the scale of human days. In the next step, we will explore how the Milky Way moves and rotates, not just through its own spiral dance, but also through the wider universe, as it journeys toward its cosmic neighbors. The Milky Way does not sit still in space, it is a traveler, always in motion, carrying us with it on a journey far grander than we can feel beneath our feet. Rotation of the galaxy. Within its own structure, the Milky Way spins like a great wheel of stars. Our solar system circles the galactic center at about 828, 0 kilometers, h 514, 0 ms. Yet we do not feel the motion. At this speed, we complete one full orbit roughly every 225 million years, a galactic year. Since Earth's birth, we have only completed about 20 of these immense circuits. Dinosaurs lived when our world was halfway around the galaxy from where it is now, moving through space. But the Milky Way is not only rotating, it is also drifting through the cosmos. Our galaxy, along with its satellites and clusters of neighbors, belongs to the local group, a small collection of about 80 galaxies bound together by gravity. Within this group, the Milky Way and its nearest giant companion, Andromeda, are on a slow-motion collision course. The two galaxies are moving toward each other at about 110 km, s 250, 0 ms per hour. Though it sounds fast, the gulf between them is so vast, about 2.5 million light-years, that the meeting will not occur for another 4 billion years. When it happens, the stars of both galaxies will pass mostly unharmed, slipping by one another in enormous arcs, while their gas and dust merge to form new generations of stars. The night sky, if any beings watch it then, will be transformed into a tapestry of colliding spirals, larger motions, toward the Virgo cluster. Even the local group itself is not still. It drifts as part of a greater structure, the Virgo supercluster, a sprawling collection of thousands of galaxies. The Milky Way is drawn by gravity toward a mysterious region called the Great Attractor, where mass concentrations bend the paths of galaxies like leaves caught in a vast current. At this level, distances span hundreds of millions of light-years, and yet the pull is steady and sure, the comfort of being carried. We, sitting on a small planet, circling a medium star in a suburban arm, are part of all these layers of motion. Earth around the sun around the galaxy within the local group within the supercluster. The motions are immense, but they carry us gently, like a raft upon an ocean we cannot see. We need not steer. Gravity has written the paths long before us. In the next step, we will step even farther back, leaving the Milky Way's local family and exploring the cosmic web of galaxies, where the Milky Way is but one glowing bead on filaments that span the universe. When we step back even farther, beyond the Milky Way's suburbs and its local group of galaxies, a larger pattern begins to emerge, a cosmic web, so vast that it redefines what we think of as structure. The cosmic web. Galaxies are not scattered randomly across the universe. Instead, they gather along filaments of gravity, forming a grand lattice that stretches for billions of light-years. Imagine a spider's web woven of light, strands filled with galaxy clusters, nodes glowing where superclusters meet, and great cosmic voids in between regions so empty they span hundreds of millions of light-years with only a handful of galaxies drifting within. Our supercluster, Laniakea. The Milky Way belongs to the Laniakea supercluster, a sprawling region that spans about 500 million light-years and contains over 100 zero galaxies. The name, from Hawaiian, means immeasurable heaven, a reminder that the scales here are beyond ordinary thought. Within Laniakea, gravity guides the flow of galaxies like rivers flowing downhill, all streaming toward a dense region we call the Great Attractor. Galaxies as islands, yet connected. Each galaxy, from our Milky Way to distant spirals and ellipticals, is like an island in this vast ocean. Yet the cosmic web shows that they are not isolated. They are connected by the invisible threads of dark matter and gravity, drawn together in ways that mirror the patterns of rivers and roots, veins and branches. The universe, on its largest scales, looks alive, looking into the past. When we see distant galaxies along these filaments, we are also looking back in time. Light from the farthest galaxies takes billions of years to reach us. Some of the faint glimmers we capture today began their journey when the universe was young, less than 1 billion years old. To look outward across the web is to read the universe's diary, page by page, with each galaxy a word written in starlight. The comfort of perspective. It can feel overwhelming to think of such scales. Hundreds of millions of light-years, thousands upon thousands of galaxies. Yet there is comfort too. Just as atoms build our bodies, galaxies build the universe. We are part of a pattern far larger than ourselves, a thread in the web of being. In the next step, we'll look at how astronomers have mapped this cosmic web, how they know it exists, and what it tells us about the origin and fate of the universe. To understand how we know about the cosmic web, let's step into the tools and methods astronomers use, ways of seeing that go beyond ordinary sight. Mapping the invisible. Galaxies are faint dots when seen individually, but when astronomers map tens of thousands at once, patterns emerge. By surveying the sky and recording the positions of millions of galaxies, scientists have revealed that they are not scattered randomly. Instead, they form long filaments of light, surrounding vast, nearly empty voids. These surveys, like the Sloan Digital Sky Survey, have drawn the outlines of the cosmic web, revealing a structure so large it spans billions of light-years. Redshift. Distances as time. Because light takes time to travel, distant galaxies appear as they were in the past. Their light is also stretched by the expansion of the universe, shifting toward the red end of the spectrum. By measuring this redshift, astronomers can calculate distances, building a 3D map of the cosmos. Each galaxy becomes a point on the web, each cluster a glowing knot on a vast lattice. Simulations of the universe. Computers, too, have helped us see the web. By simulating the universe under the influence of gravity and dark matter, astronomers find that galaxies naturally arrange themselves along filaments and clusters. These simulations match the maps from real surveys so closely that we know the cosmic web is not an illusion. It is the true shape of the universe. What it tells us. The web carries clues about the origin of structure. Tiny fluctuations in the early universe, ripples in the hot plasma after the Big Bang, grew under the pull of gravity into today's vast filaments. The cosmic web is the grown-up face of those ancient ripples, a bridge between the universe's birth and its present form. It also hints at the fate of the cosmos. As the universe expands, the filaments stretch, clusters grow farther apart, and the great web becomes thinner. Over trillions of years, the cosmic tapestry may fade, leaving future observers in isolated islands of galaxies unaware of the grand structure we see today. In the next step, we will journey back to those earliest ripples, to the cosmic microwave background, the afterglow of the Big Bang itself, where the seeds of the web were first sown. When we trace the filaments of the cosmic web back far enough, we arrive at the universe's earliest light, the cosmic microwave background, or CMB. This faint glow is the after-image of the Big Bang itself, a soft remnant that still bathes the cosmos in every direction. The first light. About 380 years after the Big Bang, the universe had cooled enough for protons and electrons to join into neutral atoms. Before this moment, space was a glowing fog of particles and light, constantly scattering. Once atoms formed, the fog cleared, and light was free to travel unhindered. That ancient light still exists, stretched over billions of years into the microwave part of the spectrum. It surrounds us like a cosmic whisper, the first visible echo of creation, a uniform glow with tiny fluctuations. At first glance, the CMB seems uniform, a nearly perfect blanket of warmth at about 2.7 Kelvin above absolute zero. But with sensitive instruments, astronomers have discovered tiny variations, differences in temperature of only 1 part in 100, 0. These small ripples are profoundly important. They were the seeds of all later structure. Where the CMB was slightly denser, gravity gathered matter, and over billions of years those patches grew into galaxies, clusters, and the vast web we see today. Mapping the afterglow. Space missions like COBE, WMAP, and Planck have mapped the CMB in exquisite detail, revealing a mottled pattern across the entire sky. Each patch of slightly warmer or cooler radiation is a fossilized snapshot of the infant universe. In these delicate patterns, scientists read the universe's age, shape, and contents, evidence that space is flat on large scales, and that dark matter and dark energy shape its fate. A bridge between past and present. The CMB is not just background noise. It is a bridge. It connects the fireball of the Big Bang to the galaxies of today. When you imagine the faint static on an old television screen, you're glimpsing a trace of that very afterglow, photons that have been traveling for more than 13 billion years to reach your eyes. The comfort of origins. There is deep comfort in knowing that the universe keeps its earliest memory alive, not hidden but spread gently across the sky. Every night, though we cannot see it with our eyes, we live bathed in this ancient glow. It reminds us that everything, the stars, the galaxies, ourselves, emerged from the same beginning. In the next step, we'll explore how the universe evolved after the CMB, how stars and galaxies began to form, and how the darkness gave way to the first light of creation. After the universe released its first light, the cosmic microwave background there followed a long era of darkness. The glow still filled space, but no new stars had yet been born. Matter was gathering, slowly, silently, under the pull of gravity. The cosmic dark ages, from about 380 years to a few 100 million years after the Big Bang, the cosmos entered what astronomers call the dark ages. Hydrogen and helium filled space, spread thinly, cooling steadily. There were no stars, no galaxies, no planets, only expanding darkness and invisible clouds of gas. The universe was a silent canvas, waiting for the first strokes of light. The first stars ignite. Gradually, in the densest regions, gravity pulled hydrogen together into clumps. Over time, these grew dense enough to ignite the first stars, massive, brilliant, short-lived giants known as population 3 stars. Unlike later stars, they contained almost no heavy elements, only the raw hydrogen and helium of the early universe. These stars were enormous, sometimes hundreds of times more massive than the Sun, burning hot and bright. They lived fast and died violently, exploding as supernovae that enriched their surroundings with the first heavy elements. In their light, the darkness of the cosmic night began to lift. Reionization. The universe clears. The radiation from these early stars and galaxies had a profound effect. It ionized the surrounding hydrogen, stripping electrons from atoms, making the universe transparent once more. This period, called the Epoch of Reionization, unfolded between 400 million and 1 billion years after the Big Bang. It marked the end of the Dark Ages and the true beginning of a luminous cosmos. The first galaxies. As the first stars formed in clusters, their gravity pulled them together into proto-galaxies. These were the seeds of the galaxies we see today, faint smudges of light in the deep sky. With each generation of stars, the universe grew more complex. New elements, new chemistry, new possibilities. A universe awakens. By the time the universe was about 1 billion years old, galaxies were forming in great numbers. The cosmic web we see today began to glow with rivers of starlight. The quiet darkness had ended, and the universe had entered an age of stars and structure, a transformation from a simple beginning to a cosmos rich with variety. In the next step, we will follow this story into the growth of galaxies themselves, how small clumps merged into giants, and how the Milky Way began its own long journey as one of countless cosmic islands. As galaxies began to appear in that first billion years, they did not remain small and solitary. The universe itself was restless, and gravity was the architect, drawing galaxies together, merging and reshaping them into larger, grander structures. Building blocks of giants. The earliest galaxies were faint, irregular clumps, collections of young stars surrounded by gas. Over time, they collided and merged, like drops of water joining into streams. Each merger sparked bursts of star formation, igniting galaxies into brilliant patches of light. From these early gatherings, the great spirals and ellipticals of today were born. The Milky Way's origins, our Milky Way, is the product of such a history. It began as smaller proto-galaxies that merged again and again over billions of years. Each collision added new stars, new gas, and sometimes entire clusters that still circle the galaxy in its halo. Even now, traces of these mergers remain. Stellar streams, ribbons of stars stretched across the sky. the lingering footprints of long-absorbed companions. The role of dark matter. Dark matter shaped this growth. Though invisible, it provided the gravitational wells into which gas and stars could fall. Galaxies formed along the filaments of the cosmic web, clustering where dark matter was most dense. Without it, galaxies would not have gathered so quickly or so richly. The Milky Way itself sits inside a vast halo of dark matter, a hidden skeleton guiding its evolution. Collisions that create. Unlike human collisions, galactic mergers are not destructive in the same way. Stars are so far apart that they rarely collide directly. Instead, their orbits are stirred, their gas compressed, their shapes transformed. A spiral may become warped, an elliptical may swell from the blending of two smaller systems. Each collision writes a new chapter in the cosmic story. A galaxy still growing, the Milky Way's story is not finished. Even now, it continues to feed on smaller galaxies. The Sagittarius dwarf galaxy is currently being torn apart, its stars stretched into streams that weave through our own. In billions of years, the ultimate merger with Andromeda will transform both galaxies into a single, larger, elliptical system. The process is slow, patient, and creative gravity's art on the grandest scale. In the next step, we will turn from galaxies as a whole to the life of stars within them, tracing how they form, live, and die, and how their cycles give galaxies their ever-changing light. Inside every galaxy, the real story is written in the lives of stars. They are the actors on the cosmic stage, born in clouds of gas, burning for spans that dwarf civilizations, and ending in ways both gentle and violent. Their cycles give galaxies their light, their color, and even the raw ingredients for worlds. Birth. From clouds to stars. All stars begin in nebulae, vast clouds of gas and dust. Gravity draws the material together, forming dense clumps. As they shrink, pressure builds, and their cores grow hot. When the temperature soars high enough, hydrogen atoms fuse into helium, releasing light and heat. At that moment, a star is born, gravity and fusion held in balance. Life, a balance of forces. For most of a star's life, this balance continues. The inward pull of gravity matches the outward push of fusion. Our Sun, a modest yellow star, has lived in this steady phase for about 4.6 billion years and will continue for another 5 billion. More massive stars blaze hotter and brighter, but exhaust their fuel quickly. Smaller stars, faint red dwarfs, sip their fuel so slowly they can shine for trillions of years longer than the universe has existed so far. Death. Different paths. The end of a star's life depends on its size. Small and medium stars, like the Sun, swell into red giants, shedding their outer layers into space as glowing shells called planetary nebulae. What remains is a white dwarf, a hot, dense ember that slowly fades over billions of years. Massive stars collapse into supernovae, blasting their outer layers into the galaxy. Their cores become either neutron stars or black holes, extreme objects that continue shaping space around them long after the explosion has faded. The cycle of enrichment. Every death feeds the galaxy. The carbon in our cells, the iron in our blood, the oxygen we breathe, all forged in stars and scattered by their endings. Each new generation of stars forms from material enriched by the last. In this way, galaxies are not just collections of stars, but ecosystems, cycling matter through birth, life, and death, endlessly renewing. The comfort of continuity. To think of stars in this way is to see them as part of a vast rhythm. We, too, are part of that rhythm. The atoms in our bodies were born in stars long gone. The atoms of our world will one day return to the galaxy to form something new. Nothing is wasted. Nothing is truly lost. In the next step, we'll follow this cycle beyond stars and galaxies, exploring how it connects to the larger fate of the universe. The question of how everything, from stars to galaxies to the cosmos itself, will evolve across unimaginable spans of time. Beyond the cycles of stars and galaxies lies a question even larger. What is the fate of the universe itself? Just as stars are born, live, and die, so too must the cosmos follow its own path across time. The expanding universe. Ever since the Big Bang, the universe has been expanding. Galaxies drift apart, carried by the stretching of space itself. At first, scientists thought gravity might slow this expansion, perhaps even reversing it in a grand collapse. But discoveries in the late 20th century revealed a surprising twist. Not only is the universe expanding, it is accelerating. Dark energy, the mysterious driver. This acceleration is powered by something we call dark energy, a force we do not yet fully understand. It acts like a hidden pressure in space, pushing galaxies apart faster and faster. Today, dark energy makes up nearly 70% of the universe's total content, shaping its future more than stars, gas, or even dark matter. Possible futures. Astronomers consider several scenarios. The Big Freeze. If dark energy continues as it does now, galaxies will drift ever farther apart. Stars will burn out, galaxies will grow dark, and the universe will cool toward emptiness, a quiet, endless night. The Big Rip. If dark energy grows stronger over time, it could eventually tear galaxies, stars, planets, even atoms apart, unraveling the fabric of matter itself. The Big Crunch. Less likely with current evidence. If dark energy were to fade and gravity regain dominance, the universe could reverse its expansion, collapsing back into heat and fire, perhaps beginning the cycle again. Timescales. Beyond imagination. These fates unfold over trillions upon trillions of years. By then, the Milky Way and Andromeda will have long since merged. Stars will have burned their fuel, and black holes will dominate. Even those, in time, will evaporate through a slow process called Hawking radiation, leaving behind only a thin mist of particles. The comfort of the present. Though these futures sound vast and distant, they are not cause for despair. Instead, they remind us of the rarity and beauty of the present moment. We live in a universe still rich with starlight, still filled with galaxies, still vibrant with the cycles of birth and renewal. To exist now is to be part of the universe at its most luminous age. In the next step, we'll turn from the distant future back to the present moment of wonder, our place here, on a small blue world, in the middle of a galaxy, in the middle of a universe still alive with light. From the vast sweep of cosmic futures, let us gently return to the present moment of wonder, to our small blue world, spinning quietly inside this luminous age of the universe. A precious window of light. We live at a time when the night sky is still rich with stars. Galaxies shine brightly, nebulae glow with color, and clusters sparkle like jewels. Billions of years from now, much of this will fade, as stars burn out and galaxies drift apart. But here, now, we exist in the universe's vibrant middle age, when the cosmos is full of radiance and variety. Our place in the galaxy, on a quiet arm of the Milky Way, orbiting a modest yellow star, Earth carries oceans, forests, and minds capable of wonder. From this small world, we can look outward and trace the history of everything, from the first ripples after the Big Bang to the stars being born tonight in the Orion Nebula. The scale is immense, but our connection is intimate. The iron in our blood, the calcium in our bones, the oxygen we breathe, all forged in ancient stars, reminds us that we belong to this story. The human moment. Though we cannot feel the galaxy's rotation or the universe's expansion, we feel time in our own way, the length of a day, the turn of a season, the rhythm of a heartbeat. These small measures are as real as light years and galaxies. They are the scales of our lives, nested inside the greater scales of the cosmos. To look up at the night sky is to hold both at once the intimate and the infinite woven together, a universe alive with wonder. The present is not just an accident of timing, It is a chance to see, to learn, to wonder, and to tell stories about the stars. From ancient myths to modern science, humans have always looked upward and asked questions. And in those questions lies our place in the cosmic rhythm, tiny, brief, but luminous with curiosity. In the next step, we'll let this journey fold back inward, toward a meditation on wonder itself, how science and story, knowledge and imagination come together to soothe us like a lullaby of the universe. When we turn our gaze inward, after such a vast journey, what remains is not just knowledge, but wonder, a quiet awe that binds science and story together. Science as storytelling. Every number we've touched the diameter of Earth, the span of an astronomical unit, the light years between stars are more than figures. They are words in a cosmic language, a story written in distances and timescales. When spoken gently, they become like verses of a lullaby. The galaxy is not just an object, it is a narrative, unfolding across billions of years, with chapters of birth, death, and renewal. The role of imagination. Facts alone cannot hold the weight of the cosmos. Imagination cradles them, giving them texture and warmth. A star becomes a hearth, a galaxy, a city of light, dark matter, the unseen scaffolding of a story we are still writing. Imagination transforms incomprehensible scales into images we can carry into our dreams. Wonder as a bridge. Wonder sits between knowledge and comfort. It allows us to learn without feeling lost, to contemplate infinity without being overwhelmed. It tells us that to know we are small does not diminish us. It situates us in something larger, something beautiful. In wonder, science and story meet, giving us both truth and solace. A cosmic lullaby. As you rest now, remember that the same forces shaping galaxies also flow through you. The atoms in your body were forged in stars. The rhythm of your breath echoes the cycles of the Milky Way. To sleep is to return to that rhythm, to be carried in the same currents that guide galaxies and light itself. In the next step, the final movement of this journey, we will let the story soften into a closing meditation, a reminder that the universe is not only vast but tender, and that every night, in its silence, it sings us to sleep. Now, as the journey draws to a close, let the vast sweep of galaxies and light years soften into something gentle and close. The universe has carried us outward past planets, through stars, across the Milky Way, into the cosmic web itself, and now it sets us back down, safely, on the quiet earth beneath our feet. The tender vastness. The cosmos is enormous beyond measure, yet it has always held us tenderly. The same forces that keep galaxies together shape the curve of your breath, the beat of your heart. You are not apart from the story, you are woven into it. Stardust remembering its origin. Atoms carrying the memory of fire. Silence as music. In the night sky, silence is not emptiness. It is music slowed until we can no longer hear the notes. The stars, the galaxies, even the faint afterglow of the Big Bang all sing a harmony that cradles us. To look upward is to hear it with the imagination, to feel it with the quiet part of the mind that rests most easily in wonder. A lullaby from the universe. So as you rest now, know that you are held within a story that stretches across billions of years and trillions of kilometers, yet still finds its way into your present breath. The galaxies will continue their dance. Stars will continue to be born and die. The universe will continue its unfolding. And through it all, you remain a listener, carried gently in the same current. Close your eyes and let the cosmic lullaby continue on without you for a while. Tomorrow, it will still be there, the Milky Way curving overhead, the sunlight crossing its 8-minute span, the atoms of your body glowing with a memory older than time. Sleep, and let the universe sing you to dreams.